Good afternoon, everyone. I am Mr. Blankers today, and I will be taking you through this owl pellet lab. And today is actually my birthday, so I'm 20 today.
Happy birthday!
Behave well for today. Anyway, first of all, we have a little bit of background on the lab. This is the results or findings of one study that a group of scientists did, and they were just examining the diet of owls based on the pellets, like you guys will be doing today. And they found that they, throughout the course of the year, had eaten about 1,400 mice, 143 rats, and various other rodents. So they're very efficient hunters, eating about 10 rodents a night. So we're going to get into how they went about doing this. So there's just a little example of a pellet, as you can see in here. There's some hair and then also bone fragments. But this is a little video on how the pellets are formed. So what happens is, we'll let this cycle through so it's on a loop, is the mouse comes along or whatever, and then the owl swoops down and gets it like that. And what's unique about the owl is that it actually doesn't chew it all like other birds of prey. It just swallows it whole, and it just slides down the esophagus into that yellow cavity there. And in that cavity, it digests the soft tissue, like the fats and the meat, but it doesn't have the proper enzymes to dissolve the harder tissues, like the bones and the fur. So what the owl does is it compacts it, and it surrounds all the bones and fur, so that when it comes back out, it doesn't scrape the esophagus, and it makes a pellet, which is what you guys are going to be examining today. And so, what scientists do, like she was talking about earlier, is they go out in the field and find these pellets, and to discover what the owls are eating, they examine them. So you guys should all have a pellet on your plate. And first what you're going to do is you're going to take those pellets and unwrap them. Don't do this right now, but you'll do it in a minute. You'll unwrap them, and you will break it in half, and then you'll break it in half again, and you're just going to kind of try and pick out the bones, the little bones, and be very fragile with them. So as not to break them, because they are kind of fragile and you need all the parts of them. And then, hopefully, you will be able to find a skull or different fragments of bone like this. And then you'll be using your dichotomous key, which you guys should all have a dichotomous key. And the dichotomous key, I like to refer to it like a choose your own adventure book, except you're not choosing the adventure, the bones choose them for you. So basically what you do is you look at your skull and you just follow through the numbers. So we start at number 1. Number 1 says skull does not have teeth, or skull has teeth. So looking at this example skull we have here, we see that there's very clearly some teeth. There's some teeth in the back, and then the incisor at the front. So we follow part B, skull has teeth, go on the dots, and that says go to 2, which means go to number 2. So move down to number 2. That says skull does not have a diastema, skull has a diastema. So the diastema, if you can see on the diagram at the top of your page, is this gap between the back molars and the front incisor. So does this example here have a diastema? Yes, so then where are we going to go next? So we're going to go to 4. So we go down to 4. 4 says cheek teeth are angled, or cheek teeth are lobed. So that's that other diagram on the top. It's kind of hard to tell from that diagram exactly what lobed and angled teeth are, but I have an example up here of the angled. And when you look at it, the lobed teeth are a little bit rounder and flat, kind of like arm molars that are more typical teeth. And the angled teeth are more jagged. It's kind of hard to see in that light, but it will be pretty obvious if you're looking at a sample. So lobed, so the sample we were following has what kind of teeth? Lobe teeth. So then where are we going to go next? 6. Okay, we go down to 6. And at this point we're going to start measuring things. And this says the mandible length is 10 to 16 millimeters, or the mandible length is 17 to 30 millimeters. So the mandible is, with every set of skulls, there's a pair of mandibles underneath it, like this, just like how we have in our jaw, 2 mandibles hanging down that pivot like that. So you should be able to find 2, but all you really need is 1. What we're going to be doing is measuring the length of this, as you see in the other diagram, from the tip of the incisor to the base of it. So you line that up with your measuring rod. So I try and get it lined up there. And this is actually missing the incisor, so it's kind of hard to see exactly the length, so we'll maybe give it a bonus centimeter or 2. But it looks like we're sitting at, what does it look like, about 2.5 centimeters. Okay, so we convert centimeters to millimeters. We move it 1 decimal to the right, so it's about 25 millimeters. So what does it look like? We have the skull up here. A rat. Okay, so after working through this dichotomous key, you determine that it is a rat. So then we will have up here a table that you and your partner can come report on, and you can just come up to the smartboard and just write in and put a little check mark in the category that yours was from. And then at the end of the class, we'll have class totals and see what your sample of owl pellets have been eating. So it's kind of our own little micro study. So is there any questions about the procedure? Anything worried about? And I will actually be going around helping you guys because some of the things are hard to distinguish.
Is there a chance that we would find like the top of a skull but not a mandible?
Yeah, because you are splitting them in half, you should be able to find it somewhere in there, at least one of the mandibles. But yeah, that's just, you just gotta be really careful. You should be able to find it. Anything else? Alright, so we will start on the procedure. So just reflecting on my teaching experience a little bit from earlier today. First of all, there were some things that I liked about it. I think I explained the procedure well and went step by step and really pointed out the things to look for, and it was especially very useful using the technology with the camera and the projector. But however, I think that technology kind of got in the way of personal interaction, and I could have involved the students more in the process. I kind of felt like I was just talking at them and just showing them everything, and maybe it would have been better if perhaps one of them could have come up and pointed out, say, the diastema on the example. And part of that, I think, was I was trying to get under the 7-minute deadline. So, but that's, I don't know, that's not an excuse necessarily. Also, I think when we got to the point of the measuring, as far as covering the objective that you guys are looking for, I think going into more detail with that, as far as lining it up on the ruler and converting from centimeters to millimeters and that kind of thing, because later on in the lab, there's no video of that, but they kind of had some issues figuring that part out. So besides that, the students enjoyed the lab. It was successful. We found the results we were looking for, and they had fun doing it, so I think it was a success.